Good morning, everyone. Happy Monday or Tuesday, whatever day you're watching this video. We are going to spend a little time today reviewing some of the work that you all have completed, and we're going to make sure that you understood it, that if you have questions, you have an opportunity to ask, and if you didn't do it, hopefully you're getting it done now. Okay, here we go. The easiest way to go about doing this would be to have two different screens open at the same time so that you can see on one side of your screen my review, and on the other side of the screen be able to match up your actual document. So I am going to excuse me, put my screen down here in the, I'll put myself up here. Hi, still here. Okay. I have a lot of mumbo jumbo on my screen, don't mind me. The first thing I'm going to do is open a new tab. It says it right up at the top. New tab. Nice job. Sorry. Okay, here we go. Next to the X up on the top right side where you would close out are these two little boxes, and I'm going to click on one of those and make this much smaller. Okay. And if I want to change the size of this, so I want it to go all the way down, I bring my cursor until it's a little double arrow and I can drag that down, and again I bring this over here and I drag that out. Boop, just like that. Now I am going to open another tab right in this little window, and I'm going to grab that and pull it right out and put it right next to this one. And well, would you look at that? Would you look at that? Two screens at once. Okay, most of you or some of you probably already know how to do that, but just for those who don't, here we go. And then I'm just going to, and there we are. Two screens. And now, one of these screens, you should probably go to your Google Classroom so that you can open up the documents that we are going to review. Nope, we're blocked too. Woohoo! Here we are. And here, I will put myself way over here, and actually I am going to get rid of one of my screens. You leave the double screen up, one so you can be watching my video and one so you can be correcting the work. I don't need two screens up. I only need to be able to see the worksheets we're going to be reviewing. So I'm going to close out of this, and then I hit this box and boop, I'm full screen again. Leave your screen two screens so that you can have me on one side and your open work on the other, checking the document as we go down. Okay, so I am going to start with day 1. We had a practice worksheet, okay, on accuracy, precision, qualitative, and quantitative measurements. Now, I went through and left comments on all your worksheets, etc., etc. I would expect that you are changing and reviewing those comments as we go through this. And actually, most of you had a really firm understanding of what accuracy and precision is. I did leave the definitions of the two right up here. The one thing to remember about accuracy is you have to have a known value or target that you are going for. You have to know what you are shooting for if you're going for a target, and you have to know what the known value you're expected to get is to figure out how accurate you are. So you're looking at one piece of data compared to one known value at a time. In terms of precision, excuse me, we're looking at a whole set of data and seeing how closely related all of those measurements are. So that's the big thing there. Most of you pretty much nailed that. The second page had you looking at two different aspects of properties. Excuse me. The first was whether or not it represented a chemical or physical property. The second thing you had to do was figure out if that property represented a qualitative or quantitative observation. So, chemical properties represent how a substance would become something new by undergoing that process. Whereas a physical property simply describes the substance. So the physical property is a way to describe the substance without changing its chemical makeup. Okay, so there were a few pieces in here that many of you had mistaken for the wrong property. So the first thing I want to do is just to go through your chemical and physical properties. So I'm going to highlight this column here, and just just going to highlight that. Okay, that's not what I wanted to do. There it is. We're going to highlight that there, yellow. Did that work? No. Okay, let's try that again. There it is. Okay. So I'm solely looking at chemical and physical properties. Whether or not something is magnetic is a physical property. It does not change what the substance is made of just because it's magnetic. It's just something that it does. If it's blue in color, I would say physical. It's describing what it looks like. If it smells like rotten eggs, I would also say physical. It's describing the substance. Now, you can have specific odors produced from a chemical reaction, so depending on how you were looking at the statement, you could have chosen either. If I were to ask you something like that again, I might ask you to explain your thinking behind why it was either physical or chemical. I would go physical though, like a substance like sulfur. Sulfur tends to smell very rotten eggy. Boiling point is one of the ones a lot of you got wrong. When something boils, it goes from a liquid to a gas state. It is still the same substance. When you're boiling your water on the stove to make your ramen noodles, or whatever it is you like to make, it's not turning into something other than water, which is probably good, because if you were breathing that in, it's turning into water vapor. It's slowly evaporating away. Okay, and so that's actually a physical change. To be sour in taste is a physical property as well. Now, flammability would be a chemical property. You're talking about whether or not you would ignite or combust, and when something does that, it does become something new. So mass is a physical property. You can change how much of something you have, whether I had 5 grams, 10 grams, 15 grams. It doesn't change what you have, just how much is there. Okay, so that's a physical property. Density, same thing, physical property. We're looking at the mass and volume of an object. How much mass is taking up how much space. Okay, both of those are physical properties, and so density is a physical property. The fact that something would react violently with sodium is a chemical property. If you're measuring the length, we have physical. If you're shiny or dull, that's physical. Now, melting point is the same as boiling point. It's a phase change. You're simply going from a solid to a liquid. So the substance is not changing. Again, if you were thinking about ice, ice is frozen water. You throw ice in your, glass of iced tea, and as it melts, if it changed into something new, you should be concerned. Instead, it just becomes the liquid version of itself. So that's a physical property. Explodes in water. Chemical. The volume, again, it's just the amount of space something takes up. It doesn't mean it has changed into something new. So, physical. Okay. Malleable, the idea that you can change the shape of an object, is simply physical. Hardness is a physical property. This dissolving in water is one that was commonly wrong too. When a substance dissolves in water, it does not change what it is. It's still there. It still retains its own properties, and it can still be gotten back in its original form. If you were to create a mixture of salt and water, salt water, and throw it on in a pan on your stove, and you were to boil the water away, you would be left with the same salt that you had originally mixed in. It does not change chemically. Therefore, it is a physical change. And the temperature of a liquid. Temperature is a physical characteristic. It's a physical property. So it just describes how the object is responding to its environment. Everything wants to, be in equilibrium with its environment, and so if the temperature of the environment is rising, the temperature of the liquid or the substance itself would rise. It does not change what the substance is made of. And now, let's look at qualitative, why doesn't this go down all the way, and quantitative observations. Do these properties represent a quality, a description, or do they represent a numerical measurement? Okay, so qualitative is quality, quantitative is quantity, or how much. It's a number reference. So I like differentiation between the columns, and so I'm going to make that one there blue. Okay. You can see that there's no numerical values with magnetism. You either are magnetic or you're not. And so that is a qualitative, a blue color, qualitative smelling, qualitative boiling point. Now, boiling point is the temperature at which a substance changes phase, goes from a liquid to a gas. Because it is a temperature at which this happens, boiling point is a quantitative measurement. Now, to be sour in taste, we're qualitative, flammability is qualitative, but the mass is a quantitative value, and it has a quantity, 25, in the statement. And so here we go, boop. And then density. Density is also a numerical value, and therefore would be quantitative. Let's see. Boop. Reacts violently is just what happens. There's no numerical measurements. Length, there's a number there. Luster, no. Shiny or not is not numerical. Melting point, again, is the temperature at which a solid would transition to a liquid. It is going to be a number if you're looking at information on melting point for substance. Explodes in water is qualitative. The volume is quantitative. To be malleable, you either can or cannot be have your shape changed. Hardness. I'm going to have to look that one up. Dissolving in water. It either does or it doesn't. However, if you're looking specifically at solubility, solubility represents a temperature at which a substance will saturate a solution. So if it was solely solubility, a lot of S words there, sorry, then that would be numerical, that would be quantitative. However, just the fact that it dissolves is qualitative. And then here, the temperature of the liquid, there you go.